Guys! So I have no idea where my notes went from that day. I tried to see, I think we got, so you guys remember we started with this? We already know the answer to this. But just to show you, one really good thing you can do in math, and as a teacher, you got to be careful if any of you guys are thinking about becoming a teacher. When you do a problem that you already know the answer to, you're always going to have some students like, wait, what are you doing this shit for? You already know the answer. So it's, if the process works, it should work independent of what the answer looks like. So we have a process that's going to work for us in situations where nothing else would work. But it should also work where they did work. It should agree with what we already got. So we can kind of get a feel for how the process works, while also at the end, I can see if the answer makes sense, because we already know what the answer is supposed to be. Does that make sense? Maybe, okay. So I'm pretty sure we made it at least to that point. So what we did was we assumed an answer of that form. We took the appropriate derivatives, we threw them in. This was me doing what? What did I do here so far? Is this cool? I don't know if you guys are having your notes from so long ago, 2 days ago. Did we make it to this point?
Yeah.
I think we might have made it further, but I just want to.
Yeah, we got to like define like CN plus.
Okay, good. Just want to catch everybody up. Yes.
How do you assume the summation? Like, how do you think?
Yeah, so it depends on the problem. Most of them are going to be Maclaurin type, meaning build it around 0. They're going to have to say if it's something different. So I could certainly I can assume, if I have an initial condition, where x is, the point is 2 comma 7 or whatever, then x is 2, I want to build it around 2. Yeah, does it make sense? I can't remember, let's take a moment, let's see while you're asking me that question, how do they word it in the homework? That's a really good question. How do they word the homework?
Are you always going to assume that it's going to be x to the n times a constant?
That is the form of a power series.
Okay.
Sorry guys. Here we go, yes, there we go. So they tell you x is 0 there. Here they give you, see all the initial conditions are x equals 0? You guys see that? Everybody with me? No? Screw you, Jeff. I don't think any of these problems have a solution you have to do that's not around 0, so rejoice. Okay. So, oh my god, okay, sorry. So we definitely got to here. We got a little bit further, but just in case you weren't here the other day, I wanted to have you be able to put eyes on directly in real life. Here we are. We assumed of this, because I told you at the beginning I wanted to build it around 0. We assumed the form of it would be like this. By the way, real quick. Taylor series versus power series. Is there a difference? It's not a damn difference between them. Taylor series are just specific power series. Where does CNs come from? They can come from my imagination. They can come from what we're about to do. Taylor series, they come from things related to the derivatives. Remember creating a Taylor series? You had to take a bunch of derivatives, plug the thing in, that's how you get your C's. Are you guys at all with me? It was based on f to the n, evaluated at your input, blah, blah, divided by factorial business. So I need this, I don't know, all a Taylor series is a specific type of power series, and every damn power series looks like that. You guys do it? That's why that form would be what we would do. Now, are there other problems with generalizations where things get tweaked? Oh shit, yeah. So always assume we are learning the base level, and then there's weird shit. We'll talk a little bit about some weird shit that happens in 6.3. Let's focus here right now. Let's see. All right, so I plugged these in. I got my indices to match by shifting my n. It's really just related to like you could do a Jeff, horizontal shift. By the way, real quick, just to show you, if I want this to become n, and I think the book uses k. Screw the book. So anybody do any computer? Anybody do any computer programming? Yes, a few of you guys. Is it kind of like okay to say let n equal n plus 1? Is that okay?
Yeah.
Is it really? Back in my day, it wasn't. But to be honest, of course it's okay. That's fine. What's not good is to say go to demo. But all we're doing is we're replacing n with n plus 2 in this case, right? So watch this. Does that make sense? I want this to be x to the n, which will match with this guy. So if I replace n with n plus 2, this will become n plus 2 minus 2 is n. If I replace this n with n plus 2, solve that for n. You get n equals 0. There you go. Right? You guys kind of with me? A little bit? So there's a more mathematical way to do what I did sort of hand wavy. I said when I plug a 2 in, I get 0. Now I plug a 0 in to get 0. That's kind of like how you can do it. That's less mathematical. Or you can do it this way, which is more mathematical. I don't give a shit because they're both the same. You guys all with me? Okay. I drove some of my physics teachers crazy because some things I didn't do as mathematically as they wanted me to. And one guy said, are you comfortable with math? Well, yeah, but you don't always have to use the damn thing, do you? No. All right. No, sorry, that guy was fun. Is everything good now? Do I have to shuck off any, and I love when I say that because do I have to shuck off any terms? Do I have to take any terms out? Nope, everything's matched. The like terms and the indices match. I'm trying to catch up to where I left off. You never have enough time, Jeff, so oh well. Jeff, where did you go? Minus Cn x to the n equals n. Now, we talked about this already. This has to be a true statement no matter what the value of x is. The only way that could be a true statement then is it can't depend on x to be 0 because x could be whatever the hell it wants to be within an interval, blah, blah, blah. But so therefore, this has to be 0. So then if I set this equal to 0, add Cn, divide by this shit, I get this. You guys with me? Does anyone know what that's called? Some kind of relation. Starts with an R. Yeah, it's recursive, so it's a recurrence relation. So it's a recursively defined series, a sequence in this case. Are you guys? Okay, I don't care about the word, really. The word recursive means it kind of references itself. To create one, I referenced something earlier. So help me out. If I think this is where we ended up. Let me take this over here because I need more room. So I've got this relationship. By the way, somebody remind me. How many constants do I know should end up in the solution to this? 2. Okay. But here I apparently have an infinite number because the n could be whatever I want it to be, correct? But we already saw something, now I'm remembering where we left off. Okay. So if n is 0, I get C2 equals C0 over 2. Is everybody with me? All right. I love you guys. If n is 1, I get C3 is C1 divided by 6. If n is 2, I get C4 is C2 divided by, 12. But C2, C0, here's exactly where we left off, I think. Yes. Look at Jeff's memory finally working. It's amazing. So if I plug C0 over 2 in, of course I get C0 over. Now that's going to continue to happen, so it will end up being dependent on how many constants? 2. C0, 0, C1. Yeah. Yeah. Yeah, beautiful. So you start to see some other things happening. The bottom term is, what's 2? Isn't that 2 factorial? What's 6? 3 factorial? 24? 4 factorial? Let's do one more just to see if this holds. It equals 3. C5 would be C3PO. C3 over. Remember, this is so evil. I almost did this, so that's why I want to remind you. N is not 5, N is 3, correct? Yeah, so what do you put it, what do you get there? 20. But what was C3? C1 over 6, so I get C1 over, this is 5 times 4, and 6 is 3 times 2. But either way, I got C1 over 120. So this is C0 over 2 factorial. This is C1 over 3 factorial. Dash C0 over 4 factorial. Dash C1 over 5 factorial. Okay. How you guys doing so far? Good, okay? So, let's see. If I look at, how do I want to say this? Yeah. If I look at just the C0s, well, let's see. Let's collect what we know. Coming back to, there it is. Yeah, coming back to this. Right. This was our initial assumption, correct? This is our initial assumption. Now we can kind of splay this out a bit. So when n is 0, I get C0 x to the 0, correct? So you get C0. Is everybody with me? C1 x to the first, yes? It's fascinating, Jeff. And I get C2 x to the second, but what was C2? All right, so let me do the C0 over 2 factorial. We'll just be smarter about this. So this is over 1 factorial. This is over 0 factorial. I love it. This is 0 trying to be a 0. Plus it would be C3, but C3 of course is C1 over 3 factorial. Da 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 da. Oof. So real quick, this is, somebody had a really good question earlier. Do I need to memorize these things? Right? And of course you do not. Dear God, don't. You really should know a few of them. I'm not going to force you to memorize these. So I would always just give you the table so you can kind of check against it. Do you guys see, is this cosine and sine? Why not? Because cosine and sine involves alternating terms, alternating signs, yes. So what are these? No?
Oh, it's 1 over 1.
Is it? Yeah, it is. Okay, cool. It's even better than I thought. But it's actually cosh and sinh. Cosh and sinh. So real quick, I want to make sure you understand. This is not one series. Do you understand? This is not one series. You guys see that? One of the series involves C0s, and one of the series involves C1s. So the C0s will lead to what? Cosh. So I get C0 cosh. And of course the C1s will lead to sinh. Now real quick, somebody remind me, what did we already know the solution was to this thing? So this is from the other day. I found something. Right, we knew this. But of course, why is this answer consistent with that one? Because like I told you guys, cosh and sinh are both combinations of e to the x and e to the negative x. Are you guys kind of with me? Do you guys all get that? Say again. Hyperbolic, cos, and sine are based on e to the negative x, e to the x. Sinh is e to the x plus e to the negative x? I can't remember over 2. And cosh is e to the x minus e to the negative x. That might be the other side. Is it that way around? Thanks. You can tell. I use them all the time. They come up often enough, but they don't really come up that much. do a problem fresh. In fact, if you got this sheet, go to the other side. Don't worry about number one, let's do number two here. Try to set this up. Number two, as far as you can work with people near you. Try to set that up. And if you look at that problem, is that one we could handle in some other way? How would you do it?
I mean, you can multiply everything by x squared.
And what would that do?
Cauchy Euler.
Would it be Cauchy Euler then?
No.
What's Cauchy Euler? The degree of the polynomial term must equal the order of the derivatives, correct?
Can you do use of on x squared after you multiply by x squared?
I appreciate all of your tips. So we did a problem where we knew the answer because we could do it a different way. Now we're going to do a problem. No other way to do it. No other way to do it. Can somebody remind me real quick why x is, I call it 0, ordinary point? X equals 0 is an ordinary point.
Oh, it's the trivial.
It exists because it's this constant.
What are p of x and q of x?
E of x.
0. 0, good. Q of x is
X squared.
x squared. Does a power series exist for x squared?
No. Yeah.
Nice. Power series is any sum of some constant terms times x to a power. If I make every other constant 0 except the one that's in front of x squared, don't I get x squared?
Yes.
Isn't that a power series?
Yes.
If I define every, I need you to be with me. Any polynomial is automatically a power series. It is a very, boring or basic power series, whatever word you want to use, because most of the constants, and when I say that, I mean an infinite number, but you know what I mean. There's a finite number of constants that are not 0 to create them. Are you guys with me? It's still a frickin' series. Can some constants be 0?
Yes.
Shit, yeah! Look at cosine. Look at its power series. Doesn't it have every other term is every other constant is 0? Right? Are you guys kind of with me? You a little bit with me? So that, what would you call it? An ordinary point means that p of x and q of x, I can construct a power series centered around that point. That means it would be analytic. I'm never as concerned about the words, but you have to know the words. So when you see the word ordinary point, that means that power series can be directly constructed. And that's kind of like, makes sense I can do this method. So go ahead and try and get as far as you can. Assume the form of the answer. Don't try to solve it a different way, because you It's not very exciting.